When working with 24 volts direct current power systems, selecting the correct wire gauge is crucial for safety and performance. The appropriate wire gauge depends on several factors, including the power draw in watts, the wire length in feet, and the current capacity in amps. A wire gauge chart can provide a general guidance for determining the minimum wire gauge required. For example, if the power draw is 30 watts, the wire length is 25 feet, and the current capacity is 1.25 amps, a 16 American wire gauge, or AUG, wire is sufficient. If the power draw increases to 60 watts, with the same wire length and a current capacity of 2.5 amps, a 14 AWG wire is needed. For 90 watts 25 feet and 3.75 amps, use 12 AWG. If you're dealing with 120 watts 25 feet and 5 amps, opt for 10 AWG. At 150 watts 25 feet and 6.25 amps, an 8 AWG wire is recommended. Finally, for 180 watts 25 feet and 7.5 amps, a 6 AWG wire is the minimum. Now, let's consider a longer wire length of 50 feet. For 30 watts and 1.25 amps, a 14 AWG wire is needed. Increasing the power to 60 watts and 2.5 amps requires a 12 AWG wire. For 90 watts and 3.75 amps, use a 10 AWG wire. When the power draw is 120 watts and the current is 5 amps, an 8 AWG wire is necessary. At 150 watts and 6.25 amps, a 6 AWG wire is appropriate. Finally, for 180 watts and 7.5 amps, a 4 AWG wire is the minimum. If the wire length extends to 75 feet, different wire gauges are required. For 30 watts and 1.25 amps, use a 12 AWG wire. Increasing the power to 60 watts and 2.5 amps requires a 10 AWG wire. For 90 watts and 3.75 amps, an 8 AWG wire is recommended. When the power draw is 120 watts and the current is 5 amps, a 6 AWG wire is necessary. At 150 watts and 6.25 amps, a 4 AWG wire is appropriate, and for 180 watts and 7.5 amps, a 2 AWG wire is the minimum. Lastly, for a wire length of 100 feet, the wire gauge requirements change again. For 30 watts and 1.25 amps, a 10 AWG wire is needed. At 60 watts and 2.5 amps, use an 8 AWG wire. When the power draw is 90 watts and the current is 3.75 amps, a 6 AWG wire is recommended. For 120 watts and 5 amps, a 4 AWG wire is necessary. At 150 watts and 6.25 amps, a 2 AWG wire should be used. Finally, when the power draw is 180 watts, the wire length is 100 feet, and the current is 7.5 amps, a 1/0 AWG wire is required. These values are based on specific assumptions and should be considered as general guidance only. For exact wire size calculations, always refer to the National Electrical Code, or NEC, or consult with a qualified electrician. The NEC provides comprehensive guidelines for electrical wiring, including ampacity ratings for different wire gauges and insulation types. These ratings are based on factors such as the wire's temperature rating and the ambient temperature in which it is installed. A qualified electrician can assess your specific application and ensure that the wire gauge you select meets all applicable safety requirements. In addition to consulting the NEC and a qualified electrician, there are several other factors to consider when selecting wire gauge. Firstly, consider using stranded wire instead of solid wire. Stranded wire is more flexible and resistant to vibration, making it a better choice for applications where the wire may be subject to movement or flexing. Secondly, allow for additional wire length for future maintenance or repairs. It's always a good idea to have some extra wire available so that you can easily make changes or repairs to the wiring system without having to replace the entire run. Thirdly, if the current draw is close to the capacity of the wire gauge, consider using a larger wire gauge. Using a larger wire gauge will reduce the voltage drop in the wire and improve the performance of the connected equipment. Finally, when running multiple wires in parallel, ensure that the total current capacity of the wires does not exceed the capacity of the power supply. Running wires in parallel can increase the current carrying capacity of the wiring system, but it's important to ensure that the power supply can handle the increased current draw. Voltage drop is an important consideration when selecting wire gauge, especially for long wire runs. Voltage drop is the decrease in voltage that occurs along the length of a wire due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The amount of voltage drop in a wire depends on several factors, including the wire gauge, the current flowing through the wire, and the wire length. The larger the wire gauge, the lower the resistance and the less voltage drop. Similarly, the shorter the wire length, the less voltage drop. To calculate the voltage drop in a direct current circuit, you can use Ohm's law, which states that voltage equals current times resistance. The resistance of a wire can be calculated using the following formula: resistance equals resistivity times length divided by area. The resistivity of copper is approximately 1.724 times 10 to the negative 8 ohms meters. Once you know the resistance of the wire and the current flowing through it, you can calculate the voltage drop using Ohm's law. To minimize voltage drop, use a larger wire gauge or shorten the wire length. Another important consideration when selecting wire gauge is the ambient temperature in which the wire will be installed. The ampacity of a wire decreases as the ambient temperature increases. This is because the wire's insulation becomes less effective at dissipating heat at higher temperatures. The NEC provides ampacity correction factors for different ambient temperatures. These correction factors should be applied to the wire's ampacity rating to determine the allowable current carrying capacity at a given temperature. For example, if a wire has an ampacity rating of 20 amps at 30 degrees Celsius and the ambient temperature is 40 degrees Celsius, the ampacity correction factor might be 0.91. This means that the allowable current carrying capacity of the wire at 40 degrees Celsius is only 18.2 amps. It is important to select a wire gauge that is appropriate for the ambient temperature in which it will be installed to prevent overheating and potential fire hazards. The type of insulation used on a wire also affects its ampacity. Different insulation types have different temperature ratings. Wires with higher temperature ratings can carry more current at a given ambient temperature. The NEC specifies the allowable ampacity for different insulation types. Common insulation types include THHN, THWN, and XHHW. THHN insulation has a temperature rating of 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. THWN insulation has a temperature rating of 75 degrees Celsius in both dry and wet locations. XHHW insulation has a temperature rating of 90 degrees Celsius in dry and wet locations. When selecting wire, it is important to choose an insulation type that is appropriate for the application and the environment in which it will be installed. In addition to the factors already discussed, there are other considerations that may be relevant in specific applications. Firstly, for applications where the wire will be exposed to corrosive chemicals, it is important to select a wire with a chemical-resistant insulation. Secondly, for applications where the wire will be subject to mechanical stress, it is important to select a wire with a durable insulation and a strong conductor. Thirdly, for applications where the wire will be used in a flexible cord, it is important to select a wire that is designed for flexing and bending. Flexible cords typically use stranded wire with a fine strand count to improve flexibility. When selecting wire for any application, it is always best to consult with a qualified electrician to ensure that the wire meets all applicable safety requirements and performance standards. The information provided here is intended for general guidance only and should not be used as a substitute for professional advice. Selecting the correct wire gauge is essential for ensuring the safe and reliable operation of electrical systems. By considering the power draw, wire length, current capacity, voltage drop, ambient temperature, insulation type, and other relevant factors, you can choose a wire gauge that is appropriate for your application. Always refer to the NEC and consult with a qualified electrician for specific guidance and to ensure compliance with all applicable codes and regulations. Remember to factor in the distance the electricity needs to travel. The further the distance, the more important it is to select a thicker wire to minimize voltage drop. Voltage drop can lead to inefficient operation of your motors and controller boards, and in some cases can even damage them. When choosing a wire, consider the environment in which it will be used. If the wire will be exposed to moisture, chemicals, or extreme temperatures, be sure to select a wire that is rated for those conditions. Using the wrong type of wire can lead to corrosion, insulation breakdown, and other problems. Always check the ampacity rating of the wire you are using to ensure that it can handle the current load. Overloading a wire can cause it to overheat, which can lead to a fire. It is always better to err on the side of caution and choose a wire that has a higher ampacity rating than you think you need. Consider the type of load you are running. Motors, for example, can draw a large amount of current when they start up. Be sure to select a wire that can handle this inrush current. Motor controller boards may also have specific wiring requirements, so be sure to consult the manufacturer's instructions. If you are running multiple wires in a conduit or cable tray, you may need to direct the ampacity of the wires. This is because the heat generated by the wires can build up in the confined space, which can reduce the current carrying capacity. The NEC provides tables that specify the dare-to factors for different numbers of wires and different conduit sizes. When in doubt, it is always best to consult with a qualified electrician. They can help you to determine the correct wire gauge and wiring methods for your specific application. They can also ensure that your wiring complies with all applicable codes and regulations. When connecting wires, be sure to use proper wiring techniques. Make sure that the connections are tight and secure, and that the wires are properly insulated. Loose or poorly insulated connections can create a fire hazard. Regularly inspect your wiring to ensure that it is in good condition. Look for signs of damage, such as frayed insulation, loose connections, or corrosion. If you find any problems, have them repaired immediately by a qualified electrician. It's important to recognize that the chart provided is a simplified guide. Real-world applications often involve more complex calculations. Factors such as conduit fill, bundling of conductors, and specific equipment requirements can all impact the appropriate wire gauge. The NEC provides detailed tables and guidelines for these scenarios. Never assume that the general guidance is sufficient for every situation. Always verify your calculations with the NEC and a qualified electrician. The NEC is updated regularly to reflect changes in technology and best practices. Staying current with the latest edition of the NEC is crucial for ensuring electrical safety. Electrical work should only be performed by qualified individuals. Working with electricity can be dangerous, and improper wiring can lead to serious injury or death. If you are not comfortable working with electricity, hire a qualified electrician to do the job. Selecting the correct wire gauge is a critical aspect of electrical safety. Taking the time to understand the factors involved and consulting with qualified professionals will help ensure that your electrical systems are safe and reliable. Remember, safety should always be your top priority when working with electricity.